I'll move it right now. Okay, so if you have a rational function, 1 over x, remember rational means fraction, variable in the denominator, and you find the area underneath it starting at 1 to wherever, question mark, that's the area is a log. So if I wanted to find ln of 3, I would just count up this area. And for scale, this box is an area of 1, right? Yeah. So we figured out the area from 1 to 2.7 is, so the definition of a logarithm is the area underneath 1 over x starting at 1.
The area between the function y over
If it fits at 1, where's that?
It ends whatever you're finding the logarithm of.
Area underneath.
Yep. Or you could really say, I wrote it as the area between 1 over x and the x-axis.
and it starts at x equals 1.
Yep, starting at x equals 1.
Yeah.
Area between 1.
Between 1 over x
What if you're having a negative?
and the x-axis.
Wait,
Well, then
can't
you
do
go
that.
backwards. Then the visual doesn't help you at all.
You can't, wait, didn't you say you can't do natural?
Logs of a negative? Yep, you can't do it for a negative. Yep. Isa.
What's the difference between like ln something and log something?
Great. Okay, let's talk about, there's an alternate definition, okay, of logs. So this is a cool definition, and it explains why ln is a thing. Because if you end at e, that's where the area is 1, so that means e is special. Remember, e was 2.718. So if we went from 1 to e, you get an area of exactly 1, so that's why e is special. Okay, but the other definition of a logarithm is the definition of a log is the inverse of an exponential. I'll explain that. The inverse of an exponential. So inverse, I mean in theory you learn this in pre-calc, but inverse means like opposite, right? But there's different kinds of opposites in math. There's like opposite signs, like reciprocal is kind of an opposite, right? If you switch x and y, that would be like kind of opposite. That's what inverse means. So let's define inverse. Define inverse. Switch x and y. Switch x and y. So for instance, if you have so the point 1 comma 10 is on y equals 10 to the x. Okay, I'm going to give an example. So 10, you can just write this wherever. There's no spot. So y equals 10 to the x. This is an exponential. Exponentials. So inverse, we know what inverse means now. Switch x and y. Kind of, we know what it means. An exponential is an equation where x is in the exponent. Not just that it has an exponent, the variables in the exponent. So like x squared, see how this has an exponent?
Yeah.
That is not an exponential. We call it a quadratic, right? So if the variable's in the exponent, it's an exponential. All right, so the point, so the inverse of this would be y equals log of x, and the point 10 comma 1 would be on that. That's what I mean by inverse, like switching x and y. So wherever exponentials are, you switch all the x's and y's, and that's where logs are. So these are inverses. So to give you an example, Isa, with log versus ln, okay? So log without a base, if the base you can't be seen, it's a 10. These are inverses, okay? So 10 to the x, like this grows very fast. At an input of 1, you're already at 10. At an input of 2, you're already at 100. Input of 3, you're at 1,000, okay? Versus, there's another set of inverses. So y equals e to the x is the inverse of y equals ln of x. So ln and log just have different bases, which means they have different growth rates.
So the base of ln is e.
Exactly.
Log n.
Yep. That's it. And lots of times you'll do like y equals log base 2 of x. There can be a little subscript, and that would be the inverse of 2 to the x. Okay? So these all have different growth rates. Actually, I'll just real quick this will actually end up being faster than so if I have y equals log of x, see how flat it is? Because y equals 10 to the x grows just like very quickly. So if I do y equals ln of x, the base is 2.718. So it grows a little faster, and then y equals e to the x. So the purple and green are inverses. Okay? So, yeah. So they're pretty similar. They just have, and notice how the key point's the same, but the growth rate's like slightly different. The shape's the same. Okay, so that's the difference between ln and log is the base. Cool. All right, let's do some logarithm properties, and then that's still pre-calc, and then we will get into calculus. Look at my cute kids, by the way. Where's my cute kids? Oh, the balloons, the stuffed animal, so cute, so cute. Okay, logarithm properties. This one you probably, did we go over this last time? Yes.
That's the last.
And you probably, if you remember anything about logs from last year, it might have been this. Maybe. Log properties. Jacqueline remembered.
Of course she remembered.
Maybe Chris learned it over the summer. Does Chris remember? No. Great.
Chris, what did you do over the summer?
Learned pre-calc.
You have to go to like that other high school?
No, I went on one.
Wait, you did pre-calc over the summer?
You sure did.
It was probably more than we learned.
I didn't learn anything.
Okay, so, okay. All right, I have mantras for this. Okay, so I have things I like to say, and we're going to do a repeat in a second. So log of a product, so ln is a logarithm. So I don't always say ln, it's just sometimes called log, because it is a log, it's just base e. So log of a product equals the sum of 2 logs. I'll tell you when to repeat. Yeah. I like the mantra because like 1 log turns into like 2 logs, right? This is kind of like exponentials. If you have 2 to the 7th times 2 to the 10th is equals 2 to the 17th. So see how I have 2 twice, and then I have it once. It's kind of like that. You have 2 twice, and you have it once. Okay.
Because don't if you have the same base and it's like a variable, you can like set the base equal to each other.
Yeah, totally. Yes. Change of bases. Yes. Change of base. Okay. So we're going to repeat in a second. Log of a product is the sum of 2 logs. Go.
Log of a product is the sum of 2 logs.
Okay. Now you're going to repeat. Log of a quotient is the difference of 2 logs. Go.
Log of a quotient is the difference of 2 logs.
Okay.
I don't hear you.
And then this one. Do a little. This one, I don't have a mantra for this. I just like visualize the arrow making it a coefficient out in front.
Like
So
the
n is the base.
What's that?
Is n the base of that somewhere?
Nope. N is an exponent of your argument, so it's
Can you do
inside.
it with numbers? Like show us with numbers?
Yeah, that's the next slide. Let's do it with numbers in the next slide. Okay, so like ln of 3 over 8. This is log of a quotient, right?
ln.
Which
Yep.
means it's the
ln of 3
difference
by
of
ln of 8.
Yes.
Oh,
So this is the difference of 2 logs. Oh, I think that pops up if I, pretty sure it pops up. Yes.
Look at that, so sexy.
Oh, learning.
Learning.
Oh,
Love learning.
that too.
Okay.
Yeah.
The animations. Okay. All right. The next one has 2 steps. So the first step right above the line.
So
So this is log of a quotient again, right? Ready to rewrite it as the difference of two logs? Go.
How do we do that?
Yeah, just like that.
What two, there's two stacks.
Yeah.
You'll see.
Because you,
Just write the first step.
You can't have L and a 4.
Yeah, well, you can have it. It's just you can simplify it.
Zero.
It's zero.
So can I just
Negative
have
L and 4.
negative L and 4 here?
Oh, I did an alternate way to do it. Oh, that's fun.
Is that only
So
work
1/4 you could change to 4 to the negative 1, right?
Does that only work with 1 though?
Yeah.
that's.
I mean, you could always do it using these two methods, but it wouldn't end up nice and clean if it weren't to 1. So see how 1/4 could be 4 to the negative 1? You take the negative 1 and just put it out in front.
Yeah.
Yes, cool, right? Okay,
What's ln of e?
1.
Oh, 1, right?
Yep, ln of e is 1. Good question. Okay, the next one, I'm going to rewrite it first.
Is ln of 1 always 0? Or like log of 1?
Any logarithm of 1 is always 0. Yep, any kind of log. Okay, so this one, I'm going to rewrite this first as ln of 3x squared plus 1 all to the,
Second. No, 1/2.
1/2.
Oh yeah, 1/2.
This is what I forgot to do on the benchmark.
Oh, rewrite it?
I
Yeah.
didn't know how to rewrite it.
So square root's exponent of a half, right? Yeah.
Square root.
Yeah, like I need a
It's
refresh
excellent.
on how to
We always
do
forget
all
that
like the
this
1/2 negative.
Oh, wow. Oof. Okay, yeah, you do need to refresh that.
Oh, in the.
Studying's good for that.
That's where I.
Okay, so guys, I'm going to use the power rule and put the half out in front.
So then
1/2 ln of x squared plus 1. Yep. And you cannot simplify that further, okay? Because you don't have a product or a quotient as the argument. The argument is what's inside.
Why do you put it in the front?
Wait, how?
Then don't you have to subtract one?
Wait, what rule did you use?
The power rule. I used this one.
Thing.
I'm thinking derivative.
I'm thinking.
Yeah, I know. Yeah.
I'm thinking derivative.
That's what I'm
Yeah.
doing.
No, we're not taking a derivative. This is equivalent. It's not like a y and a y prime or something. Yeah. Okay. So the next one has a couple steps. So it's log of a quotient. So please rewrite this as the difference of two logs. Log of a quotient is the difference of two logs. Log of a quotient is the difference of two logs.
Oh wait, this is so cool.
I think so.
I'm stuck now.
So did you write it as ln of 2x minus ln of 5? Great. You can do another step. Look at ln of 2x. That's log of a product, right?
Oh, yeah, so it can be a
You could change, so you can break ln of 2x into the sum of the two logs.
and 2.
Yep, do that.
Do that.
All right, and I have the answer written on the board now. Mm-hmm. All right, so in a nutshell, those are all our log properties.
Quick question.
If I was, yeah,
Parentheses, is that bad?
no, parentheses are great. Love parentheses.
I think I always use them the wrong word. I never
No.
put them right. I never put them
Okay, so ready to learn the calculus? So we haven't learned this yet, but area is kind of like the opposite of rate of change. It's area is gonna. Okay, so just from here, we learned that there's a tight relationship between 1 over x and ln, right? So it turns out, you ready to learn what the derivative of natural log is? 1 over x. Great. I should bring it closer the other way.
Why? Why is it the absolute value?
Yeah, I'll explain that in a sec. So the derivative of ln absolute value of x is 1 over x. So you could write ln two different ways. You could write, so just for starters, negatives and 0 are not in the domain of ln, right? Like they're not. So every time, to be like mathematically rigorous, if you write like the square root of x, you should always say like x has to be greater than or equal to 0. Every single time you should specify that, because x can be anything, right? But x actually can't be anything, you know? Like it can't be negative. So to be mathematically really correct,
I don't understand that.
But with the absolute value of x, that still includes
Oh,
0,
'cause two,
doesn't it?
oh, I get it.
I know, so they say x can equal 0. Yeah, so it would be in the directions that like x cannot equal 0. Yep, you would have to say that. So to avoid saying x has to be greater than 0, you could just do the absolute value of x. And this makes us be able to put in any values of x, except for 0. Okay, so almost all the ln derivatives we use are going to be using the chain rule. So I like to memorize the derivative of ln just like with the chain rule just built in, okay? So, because x is an inside, right? So you know how you have to multiply by your g prime, or your derivative of the inside? So we're calling the inside u. So the derivative of ln of u is 1 over u times du. So that is the derivative of ln.
What is u stand for?
Whatever the inside is. I could have written it as g of x, kind of. So like, this would be my f and this would be my g. So I could have written it as like ln of g of x, which would be the derivative, would be 1 over
I'm gonna write that.
g of x, great, times g prime of x. Yeah. I changed it to UA because that's like the convention and most people do it. But B, just U is simpler than G of X, but I totally get that, yeah. G of X makes sense because that's how we learn things. So I like the mantra, the derivative of ln of u is 1 over u du. 1 over u du. Are you ready to do some derivatives of ln? All right, let's do this first one. What's my u or my g of x here? 2x. This is my u or g of x. So you ready to take the derivative? F prime of x equals 1 over u. So 1 over 2x. Notice how my absolute value goes away when I take the derivative. That's how it works. Times du or g prime. What's the derivative of the inside?
2.
2. And then I'll see if I can simplify.
1 divided by x, right?
Yeah?
I don't get it. Like, I'm just kind of a little confused.
Yeah. So the formula is basically if you're taking the derivative of ln, you do 1 over whatever's on the inside times the derivative of the inside.
Oh, okay, never mind. I got it.
Okay, you ready to find f prime on your own? Yeah. All right, do the next one. 1 over u du.
Wait,
Yes.
So you know how we did
that times 3 prime of x?
Yes, that's the times g prime of x. Yep.
Who is it just?
Yeah.
Oh, yeah.
So,
I tried to simplify it, but it's not, okay.
Isa, question.
my question is like,
Fine, yeah.
can you simple, like, if you, this is kind of off topic, say if
Yeah.
it's 2 and you want to simplify that by 2 and make 1.5, can you do that?
Yeah, you can totally do that.
And then,
Yep, as long as you do all of the terms which you just did, you're good. Great. All right, you ready to do the next one? This is fully simplified with the 2 on top. I just left it like that. You should not simplify it further. Because you can't divide by the 2's because the 1 isn't divisible by 2, and like you would have to, so you could make it 1 over x plus 0.5, but like we're not going to make it a complex fraction for no reason. Okay, so we're doing the third one, right? Yep, keep. Yeah, exactly. Just so you can simplify it further.
I can.
You can with 3 over 3
Is it just a?
with a 1 on top.
Oh.
Mm-hmm. Isa, are you done? Are you done?
I think so.
Are you done the whole page? Okay.
Is that correct?
It is all correct. Right, when you're done the third one, do the fourth, last one. Yeah. Yes. So 1 over negative 3x times negative 3. Okay. So, yep, exactly. So some teachers teach the derivative of ln of u as du over u. This kind of saves you a step. If you were to do this, you would say du is negative 3 and just put it right on top. But I like the times du because it really reminds us that, like, why are we doing this? It's the chain rule, you know? But this way it's kind of quicker. If you just put the du on top, it's like a little, tiny little shortcut. Just want to show that real quick. Because have you noticed that this thing always just goes on top? Yeah. So you could just do du over u if you want. But again, I like the times du because it reminds us, like, it's like the chain rule. Okay, next one, let's do some more derivatives. Okay, so far that wasn't too bad, right? Yeah, derivative of ln is not too bad. All right, let's take the derivative of ln with our rules. What rule do I have to use to find the derivative of x ln x? Yeah, that's a times. So it's a product. Great. Ready to set up my little chart? Yep. So this is so basically what we're doing in this unit is we're going to learn derivatives of ln of x and e to the x, and we're going to do everything we've done so far with derivatives with just these functions. So everything's a throwback.
I have a question.
Yeah.
So for the seniors that aren't taking this,
Yes.
this is on the AP test, right?
Yes.
So they're like, I got like a lot of questions on this.
Sure. Yeah. Pops
Like,
up a lot.
Get to it and just be like, what?
So there are it is their own score. So it's like this is the kind of point of the year, especially where like some of them are into college, and it's like, look, I want to learn this material to like get a good AP score, so I like legit get credit, or just because I want to learn this stuff. And so there will be students who watch this video and learn it, and will do well on the AP test, and will know what to do when they encounter these problems. There will be students who don't, and the AP test is not going to be a great experience. Like it just kind of like sucks that they're going to have to skip all these questions. They just won't know.
How many questions are on the AP?
Is that?
Too many.
How many? Okay. We'll do this as a real quick aside, and then I'll
Like, we ended just like had to skip all of it. She came out of the test.
Hannah
she
took
was
the
like,
AP Calc test?
she took AP Calc last year, and she just said half the questions like they had never even seen those words.
What?
So they skipped 3 units.
That's a lot of units.
Because he couldn't apply them to real world, so they weren't useful.
Did her class do good?
Okay, this is,
Did she
to
do
answer Mariam's question, okay? AP exam, 45 total multiple choice questions over an hour and 45 minutes. Because like that's how long it takes to do multiple choice questions, are lengthy. We'll go over this again. But the multiple choice is divided into calculator and non-calculator. So non-calculator, 30 questions. Calculator, 15. Okay? And those are separate. Like you can't go back, you can't like cross-pollinate. Like once this is done, it's done, right? And then you have the FRQ. 2 problems with a calculator, 4 problems without a calculator. And they're equal amount of points. This is 50% of the points, this 50% of the points.
They're gonna be like, cause you only had 6 FRQs, that means they're gonna be those A, B, C, D type ones.
Oh yeah. Oh yeah. And we'll go over, you can, I can predict that like you know this increasing, decreasing maximum mins, like there's gonna be 1 FRQ on that. Pretty much guaranteed. Yes?
How much of a big part is the limit gonna be on it?
That's not a huge part.
It's
It's really not.
I
it's really not.
really do not like them. Oscar, back in please.
Yes. Okay, so let's do this. What's your U? Let's do it together. U is X. Du is 1. Yeah, well, I had to check it because Chris was wondering if it's correct, so I needed to check it. Yep, you can simplify this. That's right. Totally. Oh, this is awesome. Yeah, 3 over X.
If there's no absolute value thing, is it different?
No, it's not. That I just should put an absolute value in there. I just didn't. That's my bad. Yeah. So V is ln of X and dV is 1 over X. Yeah? So, and then crisscross and add them up. How's that, Moji? Okay. This is 3x. Oh, mm-hmm. Oh, is that extra? And then you can simplify that. So 3x squared over x cubed. Divide the x's. Just do another step. Oh, you're erasing them. Oh,
I don't know.
so did you get f prime of x equals 1 plus ln of x? Yeah, x times 1 over x
Yeah.
is 1.
So that's what I don't simplify.
Yeah, you should always simplify it. You should always simplify it because, like, most of the time, I mean, who knows? Because on multiple choice, like, you should just get used to simplifying so that you can choose the correct multiple choice answer. You know what I mean? Yeah. Okay, the next one is, yeah, it is like the ones we did back there. Yep, no special rule, just 1 over u du, or 1 over g of x times g prime of x. Mm-hmm. Our exam is Tuesday, May 9th. Just anybody's keeping track.
Put it in my diary.
Nice.
I think I put it on.
AP Calc exam, 8 a.m.
Yes, nice. Love that.
I put it as a whole day so that I get a reminder.
That's good, so the food will come.
Yeah. Yeah, it's in person, on paper, in school,
Here?
just normal. Yeah, I don't know that, probably not more than 307, but yeah, it'll be at school.
I just meant like it is.
Yep, it'll be at school.
Maybe we can sneak
You
a
say
little
what?
peek in the
All right,
classroom.
finish this. What?
Maybe we can sneak a peek in this classroom before we go.
Yeah, maybe I should just put up some posters in the classroom here.
Is it during school?
She wants
Yeah.
to fight.
Yeah, it's just a normal Tuesday.
Don't worry, I'm not gonna
I don't know. At my old school, we did that. I think we should do it. You should definitely get the day.
I should ask Mr. Vogel.
If not, you should advocate for it. I think you should like totally get the day because it's intense testing for that long.
What are we advocating for?
After the AP test, not having to go to your afternoon classes.
Yeah.
You have to go to your afternoon.
No, I don't
It's
know.
on Saturday though.
No, it's on a
Are
Tuesday.
you nuts? We literally just like.
I do not know. It might you might not have
No, I
to.
think you get the whole day.
Yeah. Okay. Good. I mean, you should.
We better. I'm not going to my class now.
Like
Okay.
the SAT
Yeah. Oh yeah. Like that should be it. Yeah.
or the PSAT.
Yeah.
Well, like,
both.
like my friends all took the PSAT and then they went right back to class.
Yeah.
Gross.
We were
I
just,
Sarah,
it's
let's
easier
do
to
that.
switch schedules here though because like parents like throw fits at like huge schools. Like,
Yeah, oh,
like,
yeah.
My child out early, like.
Yes. Yeah. 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 Definitely.
Like, that's where they have to. They never have half days or anything.
Yep. Okay, I want to just show that this you could apply a log rule. So this 3, remember, can come out in front. Remember that? It's the power. So I could rewrite this as 3 ln of absolute value of x. And this would just be 3, the derivative, would be 3 times 1 over x, right?
I didn't simplify. I didn't know how.
Yeah, so the x squared and the x cubed, you can sort of divide them both by x squared.
And then there's
So-
1x.
So think of it, yeah, times x over x times x times
And
x.
then you can cross out the ones that match up.
Yes,
Brings me back to 8th grade
yes.
math.
But see if you apply the power rule of logarithms first, it's like pretty cool way to do it.
3 ln. Ah, I see.
You see,
I would definitely make the mistake of the square though.
yeah.
Like minus 1.
Okay, let's do the last one together. So the outside function, your f function is to the cubed, right? And my inside is ln of x. So this is the first time we've ever seen ln as an inside before, right? So f prime is 3 squared,
Oh.
right?
I just forgot the.
It's the
Okay, I'm not done yet. Yeah, it's just the power rule, like the calculus power rule. Yep. And then what do I put on the inside? ln of x stays the same. Times the derivative of g prime of x, or the derivative of the inside. So the inside is ln of x.
So,
What's the derivative of ln? That's it. And that can't really be simplified.
so then you just leave it as is.
Yeah. If we wanted to, you could write it as 3 ln of x squared over x. Like if that's a multiple choice answer, I'd want you to be able to recognize it. I wouldn't say that's like simpler, but it is equivalent.
It's 12.
Great. Okay, so the next slide is fun, and you should notice lots of patterns, okay? So just take some time and just go through it on your own, okay? Take a bunch of derivatives and notice patterns. Take a bunch of derivatives and notice patterns. That's a tricky one. That's a tricky one. Just all the examples coming up.
Oh, not this page.
No, nothing on this page is tricky. Noticing patterns?
Yeah.
So make sure you just fully simplify everything to notice patterns. Yeah. Do you want help simplifying? What?
So,
Yeah. So, think of x squared as x times x, okay?
so it's just 3.
School Jackie?
When Jackie?
Who cares? Okay.
You're missing all of our patterns. Don't look at the board when I go over the answers, okay?
I'm gonna face that way.
That's not how this is. Or if that's even.
Do these other two. I want you to notice pattern first. That's not true.
I don't know what that is.
Yeah, that's okay. We'll go over it. Okay. Derivative of ln of x is 1 over x. Derivative of ln of 2x is 1 over x. 1 over x. 1 over x. Okay?
Wait, that's the, wait.
Oh, that's the one. Okay.
Okay.
Times A.
I'm strong.
Now, I want to do this a different way. I can this is log of a product, right? So I can rewrite this before I take the derivative, right? I could rewrite, yes, ln of 2 plus ln of x. Yeah?
Oh, and this is
I could rewrite it. Maybe. So I'm taking the derivative of that. What's the derivative of ln of 2?
1 over 2.
Yeah, that's the mistake. Nope, not 1 over 2. Ln of 2 is a number. It is a constant. So its derivative is 0. Does that make sense?
Only ln of 1 is 0 is every constant.
No, the derivative.
Oh, the derivative.
So the derivative of any number is 0, right? So the derivative of ln of any number would be 0.
and then it'd be like a number times 0.
It's kind of like the derivative of 17 pi would be
Oh, just
0, right? Like it's tricky. Because
ln
17
is
pi
just
is a
a
number,
Yeah.
so its derivative is 0.
Oh,
That makes sense.
I see.
Yeah, because it's a constant.
That's why it's gone. Interesting.
So this would be ln of 3 plus ln of x. What's the derivative of ln of 3?
0.
And then 1 over
So
x.
see why they're all the same?
Yeah.
Oh my god, so then that means.
See why they're all, yeah.
It's like that, because of that 0.
Mm-hmm,
And because of that
mm-hmm,
rule.
mm-hmm.
Makes sense.
Do you want any of my students? Oh.
It's like the second. It's like the second great awakening.
No, that was a great awakening. You guys said, this is what teachers say while they teach.
But it's not.
The great awakening.
The great awakening.
All right, so these guys, so this is 2 over x, 3 over x, 4 over x, yeah?
Yes.
The last one would be n over x, okay? I'm going to do it a different method. Okay? So I could rewrite this as 2 ln of x, right? I could rewrite it like that, right?
Yeah.
So the derivative would be 2 times 1 over x.
And then.
That's 2 over x. This one I could rewrite as 3 ln of x, right?
See how it works.
So the derivative would be 3 times 1 over x. Nods?
Yeah.
Isn't
Okay.
that not an email?
That's nope.
Okay,
Nice.
moving on. We're going to skip this question and go on to ln of cosine of x. Yeah. Oh, wait.
I
No,
only
what's
did
up?
the first 4. I
Oh.
just got 1 over x for most of them.
Yeah, good. That's the pattern. The answer's the same for everything. All right, go ahead. Take the derivative.
Whoa. Let's do this one?
We're skipping that
I
one.
was gonna say.
You
Let's look.
cosine?
Yes? Yeah, that's good so far, Logan. Yep, yep.
Oh my god.
Right. I still even have like the Excel spreadsheet about that.
So,
There were some
if you
too.
just refine it on email. Yes, I would like to do that.
Yeah.
You don't have to go to any quality like.
Negative sign.
Negative sign.
Cosine.
You know?
Becky's also.
How many numbers are in this essay?
Six.
How do these.
Is it something like J?
I really wanted to do that. And I don't know whether.
Is that what you said?
Well, and they're not well, thought out.
Wait, do it
And
again.
they're not well thought out for students, and they're not well thought out for teachers. And I think in some way to tie it more directly to compensation
Yes. Right.
would be super, super helpful. So I think it's a
there's
compensation
a nine.
responsibility.
There's six.
Yes.
Is it six next?
Well, six is
Love it.
Thank you.
Is there five? I love that. Yes. Zero.
Yes.
Okay. Did you guys do 1 over u du?
That was like four.
All right. What'd you get?
Negative sign X over
Cosine.
Love that. Nods. Wow, everybody's on their phone. Mason, did you get that?
Quotient.
Negative sign X
So
over
loud.
I was 2 seconds on low.
Is it? Or is it negative sign X over just regular?
Is that right?
That is right.
Why exactly?
Told you.
I can simplify that. Okay, so let's learn a little bit of trig. Let's try to remember this identity. Wait, what were you gonna say, Mariah? Do you wanna explain how you got that?
Yeah, explain.
Yeah, explain.
I'll explain.
No, I'll explain.
Okay,
Okay, so,
here, do you mind if I put this underneath?
yeah,
The,
it's kind of crowded, but okay.
yeah,
So first, we use the rule that we learned today.
yep,
And so it's 1 over what's inside the absolute value, which is cosine of x.
yep,
Then, after that, you multiply it by the derivative of cosine x, which is negative sine x.
mm-hmm,
Then, after that, you multiply it, and then over 1, and then it becomes negative sine x over cosine x.
yes. Love that,
Thanks.
love that. Okay, so let's learn an identity that's a big identity. This is on your teal sheet, but this is one of the few trig things I want you to memorize. Okay? Tangent, you don't have to take out the teal sheet. Tangent, all right, look up here, everybody. Look up here. Tangent is sine over cosine.
So negative two.
So negative tangent would be the answer to this question.
Wait, tangent?
Tangent is sine over cosine. That's its definition.
Oh.
I'll prove that real quick because, this will be the last thing we do today. So you know how sine of theta is opposite over hypotenuse, right? And cosine of theta is what?
Cosine over sine.
No.
No.
SOHCAHTOA. We're doing SOHCAHTOA.
Adjacent over hypotenuse.
Adjacent over hypotenuse. Everybody, I want you to pay attention.
Oh, I.
Okay? So sine over cosine. Those cancel, right? It's like the same thing in the same place.
Yeah.
So this equals opposite over adjacent. Is opposite over adjacent anything you know of? Tangent. That's the TOA. TOA. Yes.
Yeah, but like, I forgot, like, what is that?
So this is the proof that tangent of theta is sine over cosine.
I
So-
forgot, though. What is tangent? Like, what is theta?
Tangent?
What
What
is
theta is the argument, is an angle.
Oh, any angle. That's what.
So did you write that the answer is negative tangent of theta?
Yeah.
Okay,
Well,
we
let's
have
prove negative tangent.
we have 2 minutes left. You can pack up now. We're gonna do a legit closing. You're gonna talk to your neighbor about what you learned today, and then a couple people are gonna share out. Okay?
I learned that it's
Oh, let's pick out the seniors.
Yeah, I did.
All right. Wait. Talk about what you learned. I'm serious.
Oh, the video.
What happened to around
I learned that adjacent. I learned that sine over cosine.
All right. It looks like we don't have time to all share out, but
Log is how.
Love
I
it.
learned sine over cosine is tangent.
Good. All right, so next class, we're just gonna do problems on problems on problems, like with this, okay?
Smith,